I'm going to introduce Sarah. Sarah is a principal consultant with Snowden Optiro, bringing over 15 years experience in mining operations planning and consulting for both open pit and underground mining mines across Australia and Africa. Her key area of expertise is mining electrification. Sarah has 4 years of operating and design experience with diesel electric trolley assist truck haulage operations in Zambia, followed by 6 months in Fortescue, where she assessed electrification options such as trolley assist and battery electric trucks haulage. Most recently, she completed the Cosmos Underground Electrification Study at IGO, evaluating the technical and financial feasibility of converting the Cosmos mine from diesel to battery electric. Welcome, Sarah.
Right. Hi, everybody. Welcome. Welcome today, and thanks for having me. I'm not going to talk about software, sorry. I'd like to talk about electrification as an emerging trend for us mine planning engineers. I started off as an underground engineer and then ended up through a series of accidents working in an open pit in Zambia. And one of the projects I worked on was trolley assist. So I've got quite a few years of trolley assist experience. So that was my introduction to mine electrification. But it was great to eventually get back to my underground roots and work on the Cosmos study. And thanks to rapidly advancing battery technology, underground is the area that will electrify first because the batteries are smaller. So I'm mainly going to talk about underground today, but fast forward 5 or 10 years, I think these issues are all going to be relevant for open pit as well. So why are we talking about electrification for mining? So it's not just about decarbonisation. There's a few other very important reasons as well, and I'll go through those today. Financial, regulatory and OH&S imperatives for BEVs, specifically in Western Australia. So I'll just do a little bit of a rundown about why we're looking at BEVs for underground mines. I won't go into too much detail, but I'm happy to chat more later in the questions or later on. And then we'll run through the financial, regulatory and OH&S imperatives and what does that mean for us as mine planning engineers. So why do we care about electrification? So this is a great quote from McKinsey and Company saying that mining contributes about 8% of GHG emissions, okay? And 40 to 50% of this comes from diesel combustion in mobile equipment. Obviously, the bulk of that comes from open pit because of the number and size of the trucks that we use. But yeah, some of it comes from underground as well. So how can we reduce that diesel consumption? So electrification has been around in mining for a long time. So in the underground context, we can look at shaft haulage, conveyor haulage, trolley assist haulage, tether loaders, and so on. But a relatively new technology that combines the flexibility of diesel with the decarbonisation and cost advantages of electrification is lithium-ion battery electric vehicles. So why are we talking about these now? I'm sure we've all seen an increased number of BEVs on the road here in Perth. I understand in China they're extremely common, so we're following China's lead in this. Lithium-ion batteries are becoming much cheaper. Their capacity and their range is increasing rapidly. Regenerative braking. So one of the big advantages of using batteries rather than diesel or petrol for propulsion is that we regenerate power when we brake, and we can save that power back to our battery. So we're actually getting free power. So particularly in an underground context with a haulage truck running down a decline, we can save up to 20 to 30% that goes back into our battery for use on our uphill haul on the way back. And one of the traditional disadvantages with lithium-ion batteries is the frequency that you need to charge your battery during the shift, and also the amount of time that it takes to charge that battery. So battery swapping is a very useful invention for underground mining, and it's now actually coming out into passenger and commercial truck transport as well. by swapping our depleted battery out for a fully charged battery, we can reduce the amount of time we lose for that refueling or recharging activity. So there's a whole heap of impacts for BEVs. I'll run through these quickly. Sorry, I thought I'd be able to see it in front of me, but my eyes aren't that good. So decarbonisation, obviously, we're all trying to reduce the amount of diesel greenhouse gases that we produce. So electrification is one way to do that. Of course, if you're in the middle of WA and you're generating your power with a diesel power plant, there's not a huge amount of point from a decarbonisation perspective to convert to battery electric vehicles. But if you're in, for example, Canada, where you've got a huge amount of hydroelectric power, it's very cheap, it makes a large amount of sense from a decarb perspective to swap over to electrification. Electricity is usually much, much cheaper than diesel. When I was working in Zambia, we were paying about 5 or 6 US cents per kilowatt hour. It's a lot more than that in WA, unfortunately, but it's still cheaper than diesel. You might be saving on your diesel cost, but there are other costs involved with the battery. Batteries are still pretty expensive, and they have a limited life as well, depending on how you use them. So diesel is a reasonably simple way to operate. You just fill the tank up, use it up, and then fill it up again. There's a lot more involved with batteries. Energy efficiency. So diesel's only about 30% efficient. You lose a hell heap of that energy as heat. Whereas electric motors are about 90% efficient. So even before you look at regenerative braking, you're actually saving a whole heap of energy by swapping across to electric. There are productivity advantages as well. Increased speed on grade. You see that in trolley assist in open pit, you get almost double the speed when you're connected to a trolley assist on your ramp. Results are varying in the underground environment, but I'm hearing anything from 50 to 80% increase in mines in Canada. Your loaders can dig a bit faster as well. There's a bit more torque behind you, so you improve your dig speed. So they're the positives with productivity. The disadvantages are your battery charging takes longer and you have to do it more often during the shift. So for example, a typical loader, say an 18-ton battery loader, will probably have to swap batteries maybe once or twice a shift. And depending on your truck cycle, you may need to swap batteries every single haul. So the usefulness of battery electric for truck haulage depends on your haul. And there is a capacity limitation at the moment. Deep mines are not really suitable for battery electric trucking at the moment because there's a limitation as to how many vertical meters you can travel on that one battery charge. One of the big advantages of electric motors is they are much easier to maintain than diesel. There are a greatly reduced number of moving parts that need to be looked after, so you save a lot of money on maintenance, time and cost. On the flip side, though, you need a lot more HV electricians, you need a lot more skilled people and facilities to maintain. So that's a big swap from our current, diesel fitter maintenance environment. And that's something that particularly I see being an issue in WA with all the renewable projects going on at the moment, is where are we going to find skilled people to maintain our electric fleets when they happen. Ventilation and cooling. This is the big advantage for us for underground for electrification, and I'll talk about this in a little bit more detail further on. But if we remove that diesel dilution requirement, we can significantly reduce our underground ventilation requirements. There are other things that we need to consider when we work out our ventilation quantities for underground, but that's one of the primary ones. I'll go through those in a bit more detail. Diesel equipment gives out a lot of heat. Anyone who's worked underground knows that. There's been studies done in Canada showing the air temperature around a diesel loader increasing by 3 to 4 degrees, and then a corresponding 0-degree increase around a battery electric loader. So by removing all of that heat from the equation, you can really make some big savings on your cooling, particularly in WA, where cooling is an issue. I've just put this slide in for people who aren't familiar with how we actually charge or battery swap in the underground environment. So you do need a substantial amount more of infrastructure. Okay, we need to set up charging bays. These are not small things. You need to run electrical distribution to them. There's a bit of a manual handling risk in that photo on the right. So people are coming up with all sorts of swing arms and things to move those heavy cables around. So it's not an easy swap. It's definitely going to be more complicated to all of our lives than diesel. How much does it cost? Battery electric vehicles in mining are still very expensive. When we compare battery prices for passenger cars on the road, they have come down a lot. The mining prices have not come down that much. Some of that is because we only have two main OEMs at the moment that are offering, I'll call them Australian-sized underground mining vehicles. So that's Sandvik and Epiroc. There are some smaller, some other OEMs that have smaller battery electric vehicles, but we don't tend to use those in Australia. We tend to go for the big gear. So to buy one of these, you're going to be spending an awful lot more money up front. So trucks almost double, and loaders about 70 to 75% more expensive. And that's even before you look at the additional costs involved with those batteries. Okay, so whether you hire that battery from the OEM, which is a battery as a service arrangement, or whether you buy the battery yourself and then replace it as it needs replacement, we're looking at, substantial amounts of money. On the light vehicle side, even so, you're still looking at almost double at the moment. But again, those prices should come down quite quickly now that BEVs are becoming quite common on our roads. But we're not seeing that happen yet with the traditional haulage equipment for underground. These are all the extra things that are associated with battery electric vehicles underground, and these all come with a cost. Power availability. This is actually pretty easy for us underground. We already run power everywhere to run our jumbos and our drills. So the study we did at Cosmos, we didn't actually need to put in any extra electrical distribution. We had enough with the existing layout. We did need a little bit of extra cabling on the surface, but in terms of underground, that route was already there. This is a big difference to the mines in open pits that are looking at battery electric vehicles and electric shovels and diggers at the moment. A lot of those mines have traditionally been diesel based and they don't have power distribution run across their mines. So they're looking at some really significant costs and time to put that distribution network in. Sorry, that was electrical distribution. Power availability, are you going to have enough power? Again, for open pit, you're looking at a big increase in power once battery electric trucks are available. For underground, it's obviously very mine specific, but in many cases that we've seen that the savings in ventilation and cooling actually offset that extra demand for your charging of your electric vehicles. So you're saving all the diesel and you're not actually adding much, if at all, to your total electrical demand. Charge and swap stations. Generally underground, we have 1 or 2 diesel refueling bays. You're going to need an awful lot more than that for charging and swapping bays. And the reason for that is you want to minimise the amount of non-productive time you have. So if you're operating on a particular level for a loader, you don't want to have to tram up, 200 metres to get back to the central charge bay. Doesn't matter so much when you're only refueling with diesel once a shift, once a day even. But when you're doing it multiple times in a shift, that's a big potential loss of productive time. And of course, we're going to need to do a much better job than we've done traditionally with mine-wide connectivity. So whether that's LTE networks, those things are essential. We're going to have to do a much better job managing our equipment, both in terms of a fleet management system and an electricity management system to manage the loads we've got while we're charging all of this gear. So obviously all of these things at a cost to our operations. However, we have a big potential saving in reduced ventilation and cooling, and I'll go through that. So this is just a detailed chart of the things that you need to consider when you're doing a financial evaluation. And again, I just need to reiterate this, it's very, very mine specific. So you need to start out with what your haul route and your gradients look like, you know, what the tonnage is that you're after, all of those basic things. For Cosmos, we had to put in a whole new workshop underground because we couldn't tram up to the surface because it was 1 kilometre deep. We didn't have the battery capacity to go on one battery charge all the way to surface. So putting in a workshop underground where there wasn't one previously was a really significant cost. Offset almost by the ventilation and cooling savings. And then you've got your electrical infrastructure or your charge bays as well. So that's our CapEx estimate, OPEX estimate. You're obviously saving on your diesel, but you're increasing your power consumption for battery charging, saving on maintenance, hopefully saving on downtime, and then saving on ventilation power. Then you've got those additional battery costs that I referred to earlier. So you put that all in together and you can see what you get. So for Cosmos, we found that it was still, I think, 12% more expensive to run a battery electric mine. This is from costs from 2 years ago now. So those costs are slowly coming down. And Cosmos wasn't ideal either because it was an existing mine. It already had an existing ventilation network and we weren't able to achieve all of the potential savings that we'd hoped to. So where do we think battery electric mines might make financial sense at the moment? So hot mines. So Anarping Depth in Canada, which is a new ore body extension off the Craig mine. They did 2 diesel feasibility studies looking at opening up that ore body and they couldn't make it work financially. And the reason for that was the depth and the heat associated with the ore body. Eventually they looked at the electric option and it did make sense. And Glencore actually committed a huge amount of money to developing battery electric technology because it wasn't available back in the mid-2010s when they started looking into this. But yeah, it was worth it for them, hopefully. They're still operating in the current environment, so I believe so. Your reduction in your cooling requirements can be substantial. So Anarping Depth saw that. We saw that at Cosmos as well. So the ventilation modelling and heat modelling that we did showed that we could drop our cooling requirement from 5 months of the year to 2 months of the year, and from 6 megawatt BAC down to 4.5. So that dropped one whole cooling plant out of our capital requirement and also saved us a heap on OPEX as well. Again, very mine specific and needs to be modelled, but we're talking some really serious savings there. Primary ventilation quantities. I'll talk more about how we get ventilation quantities in a moment, but if you can reduce the number or the size of your ventilation risers, you can very quickly pay off that additional capital cost for your battery electric fleet. Similarly, if you can reduce the number of fans, you can also reduce your CapEx. Secondary ventilation quantities can be affected as well. So if you go from, say you've got a truck and a loader operating at the face, you need about 42 to 45 cubes per second to ventilate that face. If you remove the diesel equipment, that actually drops back down to anywhere between 12 and 18 cubes per second. So that means you can drop the size of your secondary fan back, you can drop the size of your ducting back, you can theoretically drop the size of your development back as well. So that's a really interesting trade-off as well. Shall we drop back from a 65-tonne truck, drop back to a 42-tonne truck? How does that work out in terms of productivity versus development cost saving? And then obviously our power costs, operating costs associated with your ventilation and cooling will drop as well. So we've talked about decarbonisation, we've talked about finances. There are a few other things we need to consider as well. I won't talk about the safeguard mechanism too much. So this is obviously tied in with decarbonisation objectives. I will say that it doesn't apply to many underground mines in WA because it only applies to facilities emitting more than 100,000 tonnes of carbon equivalent per year. So I did some research. Oh, and I've spelt Goldfields. Sorry about that if there's anyone from Goldfields here. So only those larger underground mines are currently covered by that. So decarbonisation for underground mines is not a big driver at the moment for battery electric vehicles. Of course, who knows what the government will change in the next couple of years, so it could become an issue. Right, the mines regs. So apologies to those who are not from WA, but I believe the regs are still similar in the other states of Australia. So our mines regs were updated in 2022. And there's two very interesting parts of those updates. So one is the reference to eliminating risks to health and safety as far as is reasonably practicable. So what that means to my mind is if you can eliminate a risk to your worker from DPM exposure, from heat, from vibration, from noise, and you can do it at a comparable cost, what's your excuse for not doing it? How can you justify that to the regulator? So that's something that we need to think about. We're okay at the moment because, yes, it is still more expensive generally to swap over to battery electric vehicles. But that's something that we need to really think about in the years coming up. If you're looking at setting up a new mine, a new ore body, you need to be thinking about this. Ventilation. This is the other really interesting part. So we're all aware of the 0.05 cubic metres per kilowatt of diesel engine. Okay, that's one of the main reasons we work out our primary ventilation quantity and also our secondary quantity at the face. There's other reasons as well. How long will it take you to get rid of your blast fumes after blasting? Getting rid of other contaminants such as NOx, SOx, all the rest of it, silica. Heat is the other reason for ventilation. But according to the regulations, this is the primary way that you work out your primary ventilation. There's currently no regulations for BEVs anywhere in Australia that I'm aware of. And even in Canada, which has had BEVs operating underground for up to 10 years now in some mines, their regs haven't kept up either. So we have to sort of make do with what's in there. So the only regulation that applies to us that I can see is we need to keep that average air velocity of 0.3 metres per second. We may need to make it higher than that for operator comfort. We may need to go up to 0.5 metres per second. But again, that gives you that big reduction. So for a face with a truck and a loader operating, you go from 42 cubic metres per second. And then depending on the size of your heading, from 12 to 18. So that's a really substantial difference that can really affect your mining operation. The other interesting change in 2022 was that light vehicle airflow requirements used to be excluded from your total airflow calculation. They no longer are. So if you've got 15, 20, 25 light vehicles running around underground, that actually adds up to an additional 15 to 25% that you need to increase your primary ventilation capacity by. I don't know many existing mines in WA that can just do that at the flick of a switch. It's not an easy thing to fix when you've already got an established ventilation network. So looking at battery electric light vehicles is one way to avoid the consequences of that change. And on the flip side, how does this work for battery electric charging bays? With diesel, we always used to put our diesel refueling bay in return air so that if there was a fire, it would exhaust straight to surface. Do we need to continue doing that with battery charging bays? We don't know. We need to engage with the regulator and see what they're thinking. Ideally, yes, we'd love to do that, but if you've got charging bays scattered on every second or third level of your mine, are you going to be able to do that? The other thing to think about is that battery charging generates a lot of heat. So having a sufficient quantity of fresh, coolish air coming in to ventilate that battery charging bay is also going to be important. So that's the effect of the ventilation from that regulation. And then we've got Safe Work Australia. I'm sure you've all heard that these limits are changing at the end of 2026. So the current limit for diesel particulate matter is dropping by a factor of 10. That's pretty scary, I think, for everybody who's working underground as an operator. It's great for the workers, but how are we actually going to achieve that? So there's options such as filters, making sure you've got the best quality filter you can on your diesel equipment, but are we actually going to be able to achieve that? It's not easy to monitor DPM on employees and workers. Tailpipe monitoring of vehicles is pretty common. But the traditional way to measure DPM is for a person to wear a monitor over a full shift, and then the filter gets sent away, and over a period of weeks, the results will come back. So it's not exactly real-time monitoring. I've certainly had limited success with so-called continuous monitoring, and I've heard that from a few different people. So with this limit reducing, we're going to have to, us as mine operators are going to have to think about how we're actually going to keep our finger on the ball there and monitor our DPM levels. Carbon monoxide's also reducing from 30 to 20, and nitrogen oxide from 25 to 2. So I think the question we all need to think about is, are these limits actually achievable in current diesel mines underground? I know there's certainly people in Laguiers, that's the WA Mines Department, for those of you not in WA, who think that these limits have gone too far and they're not justified. They've basically been removed down to detectable limits. And there is some literature that says they don't actually need to be that low. There's no doubt that DPM is bad for you. Okay, it causes cancer, and it causes cancer pretty quickly if you're exposed to it. So getting rid of it is a great idea. One theory I've heard is that everyone expected BEVs to be in place by now. That transition has not happened as fast as everybody hoped, say, 5 years ago. It's not easy to introduce a completely new technology and change the way you run your mine. I don't have the answers, and hopefully we'll have some good discussion about this at the end. Coming up with all of those things, we've got your occupational health and safety benefits, okay? So the mines regs telling us that we need to eliminate risks to health and safety as far as is reasonably practicable. So the introduction of BEVs would get rid of all DPM exposure, okay? And then there's all the other benefits. You're reducing the heat, you're reducing the noise, you're reducing that whole body vibration you get sitting in a diesel loader or a diesel truck all day long, okay? Those things, apart from avoiding bodily injury to hearing and to muscles, they also reduce worker fatigue at the end of the day. I've heard quite a few anecdotes from Canada, people who worked with BEVs, took a job at a diesel mine because they were getting paid a bit more, and after 6 months they came back. They just couldn't go back, you know. They were going home at the end of the day actually with some energy left and time to spend with their family, which is a great outcome for everyone, I think. And I guess my last comment there is just about reduced noise. I think one of the most challenging jobs underground is those jobs being done by service people, extending vent, installing fans. It's often done in an unventilated area. You've got a diesel IT, a diesel light vehicle. You can't hear, and from a DPM exposure factor, it's not good for you. If you can replace those, your LV and your ancillary vehicles with battery electric, you remove the DPM, and you also allow communication, verbal communication between workers, and that will hopefully improve your safety as well. So where do we go from here? I would like us all just to think about BEVs if you're looking at an underground mine in particular, and think about how we might expect out those BEV costs to reduce in the next 5, 6, 7 years. And also make sure you do that detailed ventilation modelling reasonably early so you can see whether you will get those big ventilation and cooling savings. From a regulatory perspective, BEVs can assist in achieving your decarbonisation targets and minimising risk to workers' health and safety. Our vent regulations currently don't specifically consider BEVs, so that is very much a work in progress. I believe New South Wales have got a guideline coming out sometime next year, so it'll be very interesting to see what that says. And just to think about how will these 2026 reductions in Safe Work Australia's workplace exposure limits affect your operations. And I've just talked about all of the health and safety benefits that will hopefully make underground mining a much more attractive place to work for all of us. Thank you very much.